Saxon Algebra 2, Lesson 67. Welcome to today's conversation about radical denominators. A radical denominator is a denominator with a pig house, a radical in it. And as mathematicians, we don't like them. We do not like to have our denominators contaminated by these icky little radicals. And so, as you know, we have found a simple way to fix them. If we just multiply the radical times itself, and then do the same thing on the top because that's the way we roll. Got to keep it in balance. This then becomes a 3, right? Square root of 3 times the square root of 3. Well, that's square root of 9, and square root of 9 is 3, right? That's another way of thinking about it. But anytime you multiply a square root times himself, you get the number out. 2 pigs in the house is 1 pig out of the house. That's another way of thinking of it. And what we basically do is we end up with a radical in the numerator, but that's far less offensive to us than having a radical in the denominator. So this is what we've already learned. Today, we're going to figure out, what if you have something like that? Okay? What do you do? This in the denominator, pretend, all right? I'm not going to trouble us with numerators just yet. What we do is we take advantage of a concept called the conjugate. And a conjugate is a matching expression that is exactly the same except for one difference. The sign in the middle. All right? So we can dream up all kinds of crazy expressions. And they don't even have to have radicals in them if we don't want them to. Right? This one doesn't have one. Okay? The rule for creating a conjugate is that we change the middle sign only, and that's non-mathematically precise. It's this sign that's in the middle of the pair. That's the one that we change, okay? That's how we create a pair of conjugates. And conjugates kind of remind me of reciprocals because they're super useful. What they do is, as you will see, they make things go away. So don't let me put words to it. Let's just look. First example. Here is our expression. I'm going to write it up here. 1 over minus 4 plus square root of 3. I'm using this first one that we had before. All right. We have done a problem, and this is the answer that we've got. And we see, oops, there's a radical in the denominator. That is not going to fly, is it? So we multiply by the conjugate. Top and bottom. Sometimes I draw a fraction line in, sometimes I don't. I think in these cases, of these kind of problems, it's helpful because we have such a big expression over there. Okay, so we're going to multiply by the conjugate of the denominator. What we do to the top is just because whatever we're doing to the bottom, we have to do it to the top too. We're stuck doing that. Doing this to the bottom is going to make magic. Let's look and see. So what I'm going to do is I'm going to do 2 multiplications. First, I'm going to multiply the bottom, then I'm going to multiply the tops. I could say denominators and numerators, but that just seems overly fussy. Minus 4 plus the square root of 3, minus 4 minus the square root of 3. I'll bump this up a little. Let's multiply. Positive 16 minus 4 times the square root of 3, right? Minus 4 times the square root of 3. Sit down, your turn, multiply this way. The 2 negatives become a positive, but it's also 4 square root of 3. Oh, see what happened right there? That will always happen with conjugates. It's so fun. All right, and then here, square root of 3 times square root of 3. Okay, we know that's going to equal 3, and then this is going to be a minus sign. So I'm going to write that over here where the other whole number is. This all eliminates, and my new denominator is 13. Whoa. It's so much cuter than that, isn't it? All right. Now the top, however, we have problems. Not bad problems, though. In this case, John gave us a real gift. He just has a 1 for the numerator, so we don't have to do any calculation. We know that 1 times that equals that. So we know that the top in this case is going to stay minus 4 minus the square root of 3. Again, radical in the numerator, that's okay. We're not going to sweat it. And so we put these two together to get our final answer, minus 4 minus the square root of 3 over 13. That is a beautiful answer. Again, radicals in the numerator, don't sweat us, but in the denominator, we have a conniption fit. So we turned this into this. And again, I can see if you would argue how, excuse me, I might sneeze again, we'll see. How is this better than that? Well, I agree, it's kind of messier, but it doesn't have a radical in the denominator, and that's what was really yanking our chain. All right, let's do another one. Oh, there's only 2 in the whole lesson. Oh, that's sad. This lesson's gonna be over before we even know it. Flip my page. I know, I'm sure you're just so sad that this lesson is short. Ready? Next one, example 67.2. John gives us another gift. Well, it's a little bit trickier. He gives us a numerator of 3, and the denominator well, what are we going to do about this? This has 2 square roots. Is the conjugate even going to work? Well, let's trust our process. Conjugate of this, we just change the middle sign. This sign stays the same. So it's 2 square root of 3 minus square root of 2. And then we'll do that up here as well, exactly the same. All right, these match. This one's different. Sometimes we write this one and then we write the opposite here. And then sometimes students, your brain's just going in circles and you end up writing this one up here. No, these two are the ones that match. Okay, then what I always do is I always write bottom instead of denominator. And then over here I do this multiplication. And then over here I'm going to multiply what's going on in the top. We still have a pretty simple calculation for the numerator. That's what I mean by top. It's just easier to write top and bottom than to write numerator and denominator. This is going to get crazier as we go, and we'll have more complicated multiplications over here. So we'll want both sides. Okay, let's multiply the bottom. 2 square root of 3 plus square root of 2. 2 square root of 3 minus square root of 2. We always do the bottom first to make sure the conjugate did its magic, that we didn't screw something up, because this should come out to a nice, cute number. The top will always be a bit of a mess, so I do that second after I've proven my method with the bottom. Okay, this is going to become 2 pigs in the house is 1 pig out of the house. So this is going to be 2 times 2 times 3, and that is 12. Times this. Remember, when we're multiplying, we multiply pigs times pigs and wolves times wolves, even an invisible wolf of a 1. So this will become plus 2 square root of 6. Okay, she's done. Your turn. Again, pigs times pigs, wolves times wolves. 2 square root of 6 negative. Well, there's the magic, right? 2 square root of 6 negative. There it is. And then this way, 2 pigs in the house is 1 pig out of the house. So that is a 2, and it's minus. So I'm going to write minus 2. And again, we're used to writing it over here, but I just bring it over and put it with this number because they're going to combine. This drops away. 12 minus 2 is 10. That's going to be the denominator of our new number. Now we'll multiply the top, and I can see I'm multiplying a single number times this. I'll just write it out. You don't really have to be this can't see. Again, wolves times wolves, pigs times pigs. So this becomes 6 square root of 3 minus 3 square root of 2. Okay? And then we can just plop that right over the 10, skip rewriting it. That is our final answer. Yay! Is this simpler looking than this? Nah, it's arguable, but this does not have a radical in the denominator. We have rationalized the denominator. We've turned it into a rational number. These are not rational numbers. These are irrational numbers because they have infinite non-repeating digits. That's what annoys us about them, is that these are irrational numbers. That's why we don't like radicals in the denominator, because they're irrational, and that's just annoying. So we rationalize them. 10 is a lovely little rational number, right? So that's why we do what we do. Okay, guess what? I'm so sad. 67's over in 2 short examples. Ugh, it's terrible. All right, but that's all. So, you just get to go do your homework now. Lucky you. Thanks, bye.